Welcome to a Black Hole Mini Lesson by Gio Remy. So what is a black hole? A black hole isn't exactly what you think it is. Normally, people would assume that a black hole is literally a hole in space, but that isn't quite right. The term black hole refers to the fact that there's an empty space in the shape of a hole in the universe. In actuality, the center of a black hole contains a point that has no volume but a large mass, resulting in an infinite density. We call this point the singularity. The empty space around the singularity is there because all light is trapped by the intense amount of gravity from the singularity. See, the reason we see anything is because light in the visible spectrum is reflected off of objects and into our eyes. When the light is trapped in the black hole, we aren't able to see anything from it. Evidently, this makes a black hole practically invisible. So now you're wondering, if a black hole is invisible, how do we even find it? The reason we find black holes is not because of the light that's being pulled in. We find black holes because we're able to detect how the light around it is being affected. We can see how gas and stars are affected by the intense gravity also. In order to see the way the gases are affected, we look in the X-ray spectrum, which can be detected from Earth by our many telescopes. Oh no, we can detect a black hole from Earth. Does that mean it can suck us in? The answer is no. Black holes don't necessarily go around just sucking up anything in its way. There aren't any black holes that are near our solar system for it to have an effect on us, other than our discovery of them and us going crazy because our laws of physics don't work in the center of a black hole. Even if a black hole was to replace our sun and have the same mass, we'd still orbit around the same way because it would have the same gravity. Though our sun would never become a black hole because it's way too small, we need something bigger to form a black hole. When a massive star, about 25 times the size of our sun or larger, can no longer produce energy in its core, the radiation from its nuclear reactions isn't enough to keep the star energized. The gravity causes the core to collapse into a single point, thus creating the black hole. The supernova from the event may blast the star's outer layers away into space, or they may fall into the black hole, making it heavier. Now that you know the basics of a black hole, your innovative mind could be used to figure out the unanswered questions we still have about black holes. Thanks for watching. This was Gio with your mini lesson on black holes.